Hello and welcome to As for the Education Point. This is our first live session. I promise to come live in front of you to teach data structure and algorithm. Actually, I was to be online on 17th, but due to some technical issues from our side, we are unable to be online on that particular day. But nevertheless, we will continue this live session uninterrupted through the next 5 days. Okay, and I hope that you will be supporting us. Now already we have got overwhelming response from you, because our subscriber count is almost 1000. So this is only possible because of your support and love for us, and I think that it is now our turn to return something to you, and we decided to come up with this 5-day course on data structure and algorithm, and that will be taken live. So before I begin, I want to tell you that what I am in store, okay, for you in these 5 days. Now on day 1, okay, that is today, our point of discussion is what is data structure, array is the simplest data structure, asymptotic notation, stack and its function, application and implementation, queue and its function, application and implementation. That means application and implementation of stack and queue. Now while I am proceeding, you can just type your questions in the comment section, and my representative will try to answer them, or I will be trying to answer them. But remember that everything can be covered in this live session, so you can also email me, and that link will be provided by the moderator. You can also email me your question, and this is not an assignment solving session. This is just a session to clear your basics on data structure and algorithm. So only topics which are related to this particular lecture you can ask them, and I will be happy to answer them right now. Okay, so let's begin. On day 2, okay, before starting, I must also tell you that what is in store for the next 3 or 4 days. Okay, in fact 5 days. On day 2, we will be covering linked list, its different types like single linked list, double linked list, circular linked list, and also the method of insertion and deletion of nodes in those linked lists. On day 3, I will be dealing extensively on sorting, and will cover bubble sort, insertion sort, merge sort, quick sort, selection sort, and heap sort. On day 4, we will move into linear and binary search. We will also cover a brief introduction on tree. Gradually we will move into depth first search and breadth first search, and finally we will move into the tree traversal like pre-order, in-order, and post-order. On the final day of this course, we will be dealing with graphs. The minimal shortest path algorithm like Dijkstra's algorithm and Warshel's algorithm will be covered, and also the procedure of finding the minimal spanning tree from a graph in the form of Prim and Kruskal's algorithm. So without delaying or wasting much time, let's proceed on to today's agenda. Now the first question comes that what is a data structure? Why at all we need data structure? Now before going into the detail, let's recall what a data is. A data is something which is raw in nature, which are given to the computer in any form, okay, and that data when processed will be transformed into an information that we know from a very basic level. And data not necessarily means that it will be obtained from a computer only. Data can also be obtained from various other sources, and those data, okay, must be stored in the computer, okay, because we know that if data is stored manually, then the organization of the data becomes difficult. It is always better to store data in some electronic form, then it is very easy to maintain, because they are organized in a proper manner, and also they are secured. Consider that you are keeping some manual form of data in some piece of paper. So what is the negative point in this? That paper has its own wear and tear. Someone, if the paper is in someone's custody, then he or she may misplace it. That is another, that, or it may be stolen. That means there are security issues, there are organizational issues, there are management issues if data is not handled properly. So data must be handled with care so that they are properly organized and well managed, and they must be stored based on the storage format. Okay, storage format, you must be knowing that while storing data in the computer, we must keep track of the data types, because whatever data we store in the computer, they are stored in the memory based on their type, as integer takes 4 bytes, float takes 4 bytes, character takes 1 byte. So all kinds of data are having some certain storage format, and it depends on what data type it will be stored in the memory. So why we need data structure? For well organization, management, and proper storage of data, and also proper security of data. We need the data structure. Data must be organized and put in a structured format. It must be well managed. That is data structure. And also sometimes it becomes very essential to study the relationship among data. Okay, some data, say there are data of few employees in an organization, and some employee are the leaders and the other employees are the followers. Okay, so there is a relation between these two types of data, the leaders and the followers. So the relationship among the different data which we collect or whichever we keep in a data structure, that relationship must be studied carefully, and all these things will only be possible if data is stored in a well structured form. That is why we need data structure. Now let's understand the simplest form of data type. Okay, let's understand the simplest form of a data structure. Okay, and it is array. Now array, in many books you will find that it is a derived data type, and it is truly a derived data type because it is derived from the other primitive data types like integer, float, or character. But in simple sense, we can think that it is a kind of collection of data of similar kinds of elements. Suppose an array is declared as an integer, then I can safely say that it is a collection of integer elements. Now it is a collection of data, and also it is a well managed form of data, so it can also be called as the simplest data structure. In many books you will find that it is not described as data structure, and in some books you can find that it is described as data structure. So I decided to cover array as a data structure also. Now this is also pretty simple, that how memory is allocated in an array. This is very simple. I will just go through. Suppose I have declared an integer array of size 7. That means it is expected to take values between A0 and A6, and size of A0 through to A6 will be 4 bytes each. That is, A0 can hold up to 4 bytes of data, A1 can hold up to 4 bytes of data, so on and so forth. A6 is capable of holding 4 bytes of data. Also I need to declare some iteration variable, say I. Why? Because I needs to traverse between 0 to 6. That is the index of the array. It will start from 0 and it will end with 6, because the size of the array is 7. As it is written, you can see that A is the name of the array of size 7 that I already explained. So I think it is very much clear to you. Now this is an one-dimensional array when I need to keep track of only one intermediate variable. That is why it is one-dimensional array. Now data can also be stored in matrix form, that means in a row and column format. So in that case, one iteration variable is not sufficient to address all the elements of the array. We need two intermediate or iteration variables, say those two variables are I and j, and it has separate rows and columns. For the one which is already in this picture, let's highlight that portion. Let me highlight that portion. Since it is okay, it has elongated much. It is okay. At last I have got this pen. So let's highlight this. Yes. Now the number of rows and the number of columns, here are 3 cross 3, because the number of rows are 3 and the number of columns are also 3. Now how will you track the element located in 0 0? It is only possible if you can map between the rows and the columns. Then only you can understand that something is stored in 0 0. Again, how can you mark something is stored in 1 1? If you can mark that the row number is 1 and the column number is also 1, then only you can identify the element which is placed in this 1 1. Okay, that means I have to track both the rows and the columns. If I track only the row, then I am confused between these 3 elements or these 3 elements or these 3 elements, because suppose I am only given row number 0, that is the first row. Then how can I be sure that which element I am referring to? Because it can be 0 0, it can be 0 1, it can be 0 2. Again, if I am given the row number as 1, how can I track the elements? How can I distinguish the elements, that whether it is in 1 0, 1 1 or 1 2? That means I need both. I need to track it through the rows as well as the columns. Now if I track both, that is the row number is 0 and the column number is also 0, then I can easily identify that the element in question is at 0 0. Similarly, if the row is 2 and column is 1, then I can easily identify that the element in question is located in 2 1. That means it is called a two-dimensional array, because it has 2 dimensions, namely the row and the column. Okay, and I need 2 iteration variables to track them, because suppose one iteration variable I, which is tracking the row, and the other one is j, which is tracking the column. So now I won't have any problem when I will do the practicals after a few minutes. Then you can easily understand them. And regarding memory allocation, as you can see, they are stored in the memory in linear fashion. That is, first 0 0 0 1 and 0 2 are stored in memory, then 1 0 1 1 and 1 2 is stored in memory. If you observe the color carefully in the slide, you can understand that this, what color I will say this, okay, maybe light red or something. So that color is given first, then the apple green, and then the sky kind of color. Okay, so they are identifying the mapping of the rows and the columns, and they are placed in linear fashion. That is how the elements are stored in the memory also in case of two-dimensional array. Okay, and after few minutes we will move into the practicals. Then these things will be explained in a much better way also. Now let's come to the asymptotic notation. Okay, now just look at these diagrams. You can find that there are 2 functions, namely the fn and gn. Okay, in figure 1. Okay, note this portion, that is a, whichever I am highlighting. And if you look this graph x versus y, you can understand that there is a function called fn and there is also a function called gn. And what I want to mean in this, okay, I want to mean that Fn lies between C1Gn and C2Gn. Okay, from this picture it is very much clear that C2Gn is greater than Fn and Fn is in turn greater than C1Gn. Or in other words, I can say that Fn lies between C2Gn and C1Gn. That is, it is tight bound in between C2Gn and C1Gn. Okay, so what is the meaning of this? To understand the meaning of this, we have to understand algorithm also. So let me open this board. Okay, let me open one board. I already put it here. Let's open one board now to explain those diagrams. Okay, now what is an algorithm? This is a very basic thing. Okay, because before proceeding to the asymptotic notation, we must understand what an algorithm is, because most of you are already acquainted with C, I assume. If not, you can always follow my lecture on C programming, okay, which is already present in this channel. Okay, you can go through those lectures, but still I just want to repeat that what is an algorithm and what are its properties. Now, algorithm is a step-by-step procedure to write a program. That means you will have to formulate a series of steps which can help you reach the goal, or which can help you in reaching the target. Suppose I have a set of inputs. Now, how those inputs will be processed? Okay, how those inputs can be processed in a step-by-step manner so that I can reach the output. That is the main thing of any procedural programming language, that there must be a procedure which should be followed. Now, what kind of procedure? Okay, suppose in a very simple step, if I want the mean of say 10 numbers, if I want to find the mean of the 10 numbers, then the input should be 10 numbers. Okay, now you have to implement the formula to calculate the mean, that is x bar equal to x1 plus x2 plus dot dot x10 divided by 10. Okay, so that is the processing part, and finally you will have to output the result, that is x bar. So that means it will follow this algorithm that first you have to input those 10 numbers, then you have to find x bar as x1 plus x2 plus dot dot x10 by 10, and finally you have to output the x bar. So this thing is very simple. In all kinds of algorithm, remember that we have the input, okay, whose size may vary. Now, because suppose if I want to find the mean of 10 numbers, then the size of input is 10. Now, situation may arise when I need to find the mean of say 100 numbers, or maybe 1000 numbers, or maybe 1 lakh numbers. So in that case, the input size will vary from 10 to several lakhs. So the input size may vary, but the output will be that how I process those set of inputs. It is dependent on that. Naturally, you can easily understand that how much time this algorithm will require to process the mean, how much time it will require to process the mean is completely dependent on the input size. How? Because if I want to find the mean of say 10 numbers, okay, the time required to find the mean of 10 numbers is less compared to the time taken to compute the mean of say 100 numbers. Okay, now if I want to find the mean of say 1 lakh numbers, then the time required to compute the mean increases. It's not it increases. Or there, in normal sense, we can easily say that the more the input size, the time taken can increase. Okay, or in some cases it may also decrease. So better not saying that way, but in this case we can say that it may increase unless and until we follow certain techniques. Now those techniques, okay, those techniques must be implemented because our target is that the time should not vary much with respect to the size of the input. That should be the main target of the algorithm analysis and design, because if the input size increases and the time also increases, okay, in a much higher factor, then it will be very difficult to use that or put that algorithm in practice, because to find the mean of 10 numbers we will not be using a computer, right? So even if the time required is less, we are not interested in it. We will only use computers when computation becomes difficult, that is the size of the input increases. So if with the increase in the size of the input, the time also increases manifold, then what is the purpose of using an algorithm? Because the main purpose of using an algorithm is not only to solve the problem but also to solve it efficiently. Within a finite time. Because if I cannot solve the algorithm or solve the problem within a finite time, then there is no point in using a computer. So the main utility of algorithm is to solve the inputs processes, okay, to get a finite output within a finite time. It should not take infinite time when we are unable to predict that when we are going to get the answer. That unpredictable behavior is not allowed. So we will try to predict that how much time an algorithm is going to take, okay, given the size of the input. And that is algorithm analysis, that when we are given a certain set of input and we will try to find out that how much time the computer may require to process those inputs to give us a finite output. So that must be assumed beforehand. That is the number 1 point. And the number 2 point is that with the increase in the size of the input, the time required to compute the result of the algorithm should not increase in an exponential manner. It should not increase at a very fast rate. It can increase, but it can increase in a finite rate, or in certain cases when we progress in the course, you can understand that it may not increase as much as the size of the input. That is, it will be well within our control. And when our output is computed within a controlled amount of time, that means we can say that our algorithm is efficient. Now, how we calculate the efficiency of an algorithm? Let's draw one diagram. Okay, follow this board carefully as I draw the XY axis of this graph. Now please be patient as I am drawing this graph. Now you can understand that this horizontal one is the x-axis and the vertical is the y-axis. One is the dependent and another one is the independent variable. So suppose with the size of the input, the algorithm has a behavior called fn, and it looks like something like this. Suppose the behavior of the output of the function is something like this as per my diagram. Suppose it behaves something like this. This is fn and this is the time, or this is the relation of the function, that how much time it is going to take to compute the output. Suppose it is given by this function. It can be say n log n plus c, but c is a constant. It can be 3n square plus 2n plus 3, that is a quadratic function. It can be 3n plus 3, that is a linear function. So how the function will behave, that is dependent on what kind of algorithm we will write, or what is our prospective solution to solve the problem in question. So based on that, the time taken, the expected time which the algorithm may take to compute the result, okay, it will follow a certain mathematical function, we assume that, which will be asymptotically dependent. Okay, it must be asymptotic behavior, because it cannot decrease or increase at a rapid rate. At a particular finite amount of time, it will be monotonous in nature, that is it will not vary much, that we are assuming. Okay, that is, it is a monotonously increasing function. It is not that it will take a sharp turn for a given set of inputs. So the function is given by, it can be anything. It can be linear, it can be quadratic, it can be logarithmic, it can be exponential. Okay, that the time taking is given by a function fn that we are assuming. So let's mark this as fn. Let's mark this as fn. Okay, this is fn. Now suppose there is some gn, we are assuming that, let's mark this with some other color. Let's take this, follow this board very carefully. Now suppose the curve which I have drawn in green, that is cgn, that is c into gn. Now what can we infer from this? If I join this point of intersection between the green and the blue part, okay, this green and the blue part, and let's mark it as n0. Let's mark it as n0. Okay, then I can safely say that for all n greater than n0, c into gn for some constant c is always greater than fn. Is not it? Note this picture carefully, note this graph carefully, and you can easily understand what I want to say. That for any n which is greater than n0, you can see what is n0, that is the intersection of the green curve and the blue curve. For any n greater than n0, I can safely say that c into gn is greater than fn. C into gn is greater than fn for some constant c. Okay, then I can safely say that fn is order of gn. Then I can say that fn is order of gn. Let me mark that for your understanding. This one is very important as you learn algorithm analysis. If this will be very vital if you want to learn computer data structure, algorithm analysis. This is order of gn. Let me close this bracket also. Now what is the criteria for fn to be order of gn? For some finite value of n0 or for some finite input size n which is greater than n0, fn must be smaller than C into Gn, where C is a constant. Okay, now C is a constant. We have to find some value of C, okay, such that C into Gn is greater than Fn. And if it is possible for some value n0, for all n greater than n0, if we can find some C, okay, which is when multiplied by Gn is greater than Fn, we can safely say that Fn is order of G. Okay, fine. So now Fn is equal to order of Gn means that this is the big O notation. Fn equal to big O G, that is order. In other words, I can say that Gn is the asymptotic upper bound of Fn. Cgn or Gn is the asymptotic upper bound of Fn. That means big O notation will give me the asymptotic upper bound. But now what I mean by asymptotic upper bound? It means that it is the worst case complexity of a algorithm. Why it is the worst case complexity? Because I know that after n0, C into Gn is always greater than Fn. That means for no other values of Gn, we can get a worse result. We cannot get a worse result because it is the worst case when Cgn is greater than Fn for some constant C. So big O notation gives us the worst case complexity of an algorithm. Now consider, let's modify this using the red color. See what is happening here. If something like this happens, then what happens? Again you can see that for n0, this one is, let me mark this as Cg2. Okay, before I explain, let me mark this red curve as C2 into Gn. Now if this is C2 into Gn, we have to make this as C1 into Gn. Now note this carefully. Now what happens after n0? Now what happens after all n greater than n0? After all n greater than n0, Fn will be tight bound within C1Gn and C2Gn. Is not it? From the curve it is very much clear that for all n greater than n0, C1 into Gn is greater than Fn, which is in turn greater than C2 into Gn for constants C1 and C2. For constant C1 and C2, C1 into Gn is greater than Fn and Fn is in turn greater than C2 into Gn. Okay, that means Fn ranges between C1Gn and C2Gn, or in other words, Fn is range bound between the function C1Gn and C2Gn. Now this will be called, in such a case we will call Fn will be theta of, I don't know whether I will be getting theta here. Fn is equal to, let me check if you can find the formula here. This will be, I'm not getting that here, in fact. No issues, just make it theta. Okay, it will be theta Gn. It will be theta Gn. Now that means I can say that what is theta Gn? It is Fn is equal to theta of Gn, when I will say that when Fn is range bound within C1 Gn and C2 Gn. Okay, then Fn will be theta Gn. That means since Fn is between these two ranges, I can safely say that Fn in this particular case will give me the average case complexity. So what will BGO give me? It will give me the worst case complexity of an algorithm. And what will theta Gn give me? Okay, if Fn is theta of Gn, then it will give me the, then in that case that will give me a range, or it will give me a average case complexity of the algorithm. Similarly, let's consider the third case. Now if you look into this, if we join this, find out the intersection between the red line and the blue line, what you are getting, this particular point. Let's bring it down. Suppose this value is some n01. Okay, now if I carefully see what happens for all n greater than n01 for the blue line and the red line, you can see that the red line is below the blue line. Okay, for all n greater than n01. So in that case, I can safely say that Fn is greater than C2Gn for all n greater than n01. I can safely say that. So if that condition is true, then we will say that Fn is omega of Gn. In that case, we will say Fn is equal to omega Gn. Now what does omega Gn means? That C2Gn is always less than Fn. So it will give me the best case complexity of an algorithm. So omega Gn, if Fn is omega Gn, that means it will give me the best case of an algorithm analysis. It will give me the best case scenario, because in all such cases the time Fn is always greater than C2Gn, okay, for some constant C2. So that will give me the best case analysis. So to summarize, BGO, okay, will give me the worst case scenario. Theta Gn will give me the average case scenario, and omega Gn will give me the best case scenario in case of algorithm analysis. And mathematically we can say that for BGO, for all n greater than n0, if this is true, then I can tell that Fn is order of C1 Gn, and it satisfied the inequality that Fn must be less than equal to C1 Gn. Okay, and also for the best case, it must satisfy the inequality that Fn must be greater than C2 Gn. Okay, and for the asymptotic tight bound, Fn must range between C1 Gn and C2 Gn. In other words, Fn is less than C1 Gn and it is greater than C2 Gn. Now let's hide this board. Let's come back to the presentation. Now if you see and if you compare these curves, you can easily understand that whatever I have explained you, that is only written here. So in algorithm analysis, you can understand that with the increase in input size, okay, the time analysis we are interested in, that how much time the algorithm is actually needing to complete the finite number of steps. so it must be depending on the time complexity, and also sometimes the memory requirement, okay, it can also change, it can also increase, so that will be called as the space complexity. So that is all about the time and space complexity. And the analysis of algorithm mainly deals with the how much time and how much space the algorithm requires to compute or process the inputs to give me a desired output. Okay, now since we have gone through the asymptotic notations, you are in a position to look into the running time of some algorithms. As you can see this in this graph, okay, it is collected from the internet, but the basic thing is very simple. Like you can see the several big O notations like order of 1, order of log n, order of n, order of n log n, order of n square, and so on. Okay, as you can see that order of factorial n, okay, that is horrible complexity, and whereas order of log n and order of 1 are pretty good. But what does this mean? That means that when you input some n, okay, your input size is n, still your running time is constant. That is why it is order of 1, and or it is very close to 1, like order of log n. Or in case it is directly related with the input size, then it is order of n. If it is little more than that, it is order of n log n. And sometimes it is a square of the input size. In that case it is order of n square, or it is exponential or factorial or polynomial time, like order of 2 to the power n, where n can be anything, right? Or order of n to the power z, okay, it will be in polynomial time. So it varies from algorithm to algorithm. Okay, now the more time it takes, that is the running time increases more in case of the input size, in certain cases, in the ones which is marked as horrible. So that we will not be considering, that is not an efficient algorithm since its running time is not that good. But order of log n, order of 1 or order of n, they are good. So they are directly related on the input size. Okay, so for example, say order of log n, this kind of algorithm is binary search, or order of n, you are learning a simple for loop. Okay, you are iterating through a particular direction. That means that say I equal to 0 to I equal to n, so that for loop will be executed n number of times, so that running time will be order of n. Again, say merge sort, that is another algorithm, it is order of n log n, okay, or say bubble sort, it is order of n square. So this is how, these are the examples of these running times, that how this algorithm running time varies with the size of the input size n. Okay, now let's move into the stack. Now what is a stack? Consider an example. Let me open the board again for you. Let us open the board. Take a new one, or let me erase this, not an issue. Suppose I have this kind of a structure. I have few numbers. Okay, I have not selected the line, I think, so I have to select a line first. I selected the line. Now let's consider this is a line. Its value is certain, say maybe 4 or 5 or c. Now let's make a stack like structure 3 or 4. Now you can understand that I am inserting the lines from bottom to top. That means gradually I am piling up the lines one above the other. Okay, one above the other. This can be any element. This can be a pack of cards, this can be a set of books, this can be lines or anything. Now what happens? See, if I want to suddenly take out a book from a pack of 10 books piled one above the other, then what will happen? What problem I am going to face? That the last book which I am going to take, if at all I try to do it, then all the books may fall over because one book is placed above the other book. So in this kind of structure, it is very difficult to take out any element or any commodity, in our example book, from either the top of the stack or from the middle of the stack. But it is very efficient if we want to remove the book from the stack from the top. Then I can easily remove the first book, then I can remove the second book, then I can again insert some other book into the stack. So that means what? That this kind of structure is last in first out. That means whatever element I will be entering at last, I will have to remove that element first. Now consider that there are several numbers here. Suppose first I have inserted 4 here. Okay, now let's insert another number here. Suppose this is 10. Again, suppose I am inserting another number, say 11. See, I could have taught you without this also, but I think that this will be easier. So that is why you can visualize the structure in a better way. So I am using this, nothing else. If you can understand in some other way from the book example, that is well and good. Now suppose I have inserted the elements within this kind of a structure in the order that first I inserted 4, then 10, then 11, then 13 and then 15. Now if it is a stack like structure, that is it is a LIFO structure, to remove 13 I have to first remove 15. If I want to remove 11, then I have to first remove 15 and 13, then only I can remove 11. But it is not possible to remove 4, okay, suddenly from this kind of a structure, because this structure is last in first out. Okay, this structure is a stack like structure. You cannot remove the element just without following any rule. You have to follow the last in first out rule. That means whatever element you will be inserted at last, you can only remove it first. Okay, so this is a stack. Now you insert at the top of this stack. Okay, you insert at the top of the stack and you remove from the top of the stack. You insert at top, you cannot insert anything in between, and you remove from the top. That is, you cannot remove anything from the stack like structure without removing the top. First you remove the top, that means the current top. Again I want to clarify this point, that if you want to remove 10, then you have to first remove 15, 13 and 11 in order, then only you can reach 10 and you can remove it. Okay, you cannot just remove 10 from this kind of a structure. So this is a stack. Now the operations to which are actually performed, or which is permissible within this kind of a stack like structure, is that, okay, they are push and pop. Now what is push? When you want to insert anything into the stack, that is a push operation. When you want to remove an item from the stack, that is a pop operation. Okay, now this stack must be of a finite size. The stack cannot be of infinite length, is not it? The stack must be having a finite size. Say the stack of the size of the stack is 10, then you cannot insert the 11th element. Now if a programmer or if an user happens to insert or push the 11th element, then there must be an error. That error is known as the stack overflow error. Okay, that is the stack overflow. That means stack is already full, you cannot insert anything, you cannot push any element further into the stack. If you try to do it, then you will get the stack overflow error. Similarly, say the stack is already empty. I have already removed all the elements of the stack. Okay, like in this case 15, 13, 11, 10 and 4, everything is removed, but still the user has the user is trying to remove another element, that is pop, calling the pop function again when the stack is already empty. So that will give rise to another error that is known as the stack underflow error. That means you are trying to remove an item from the stack when the stack is already empty. That kind of error will be called as the stack underflow error. So 4 things we need to keep in mind. That is, first, that how we implement the push function, next how we implement the pop function, then there must be a provision to check that whether the so that the stack overflow or the stack underflow error does not occur. Okay, there must be a provision to check those kind of things. So these are the things we need to keep in mind while implementing a stack. And also the very vital point is that you can only insert at the top of the stack and you can remove from the top of the stack. That's it. Now this stack has many implementations. Okay, now if you want to check that what are the why will I learn stack, what in where practical cases do we use this kind of a data structure. Now we use this kind of data structure when we are implementing some memory stack, like in operating system, you know that there are different memory positions, okay, memory locations, and that memory is maintained in the form of a stack. That is, there is one memory location, above it there is another memory location, above it there is another memory location. Okay, so all the items are stored in the form of a stack data structure. So the foremost implementation of stack is in computer organization, in memory management. Okay, now if you go through the slide, okay, it is clearly written that stack is a container. Okay, it's last in first out, it follows last in first out principle, which I already explained you. Then it is a limited access data structure. Okay, and see why it is a limited access data structure, because the reason I have already explained you there, that elements can be added and removed from the stack only at the top. Okay, only at the top, that you can only insert element at the top and you can remove element from the top. And next thing is the push function, which adds an item to the top of the stack, and the pop removes the item from the top, that is insertion and deletion. Okay, if you go through this then you can easily understand that what are push and pop. You see that each time an element is added at the top, and whenever I am calling the pop, element is removed from the top only. And remember, it is not mentioned here, but as I told you, there must be 2 conditions which have to be checked, that is stack overflow and stack underflow. When the stack is already full, you are trying to insert something or push an element into the stack, it will give you the stack overflow error. And when the stack is already empty but still you are trying to pop something from the stack, it will give you a stack underflow error. There must be the provision made by the programmer while implementing a stack data structure. Fine. So again, the stack application, as I told you, that it helps in memory management, as most operating systems work in this way. They implement stack as a data structure while managing the memory and memory locations. And the other utility of stack or other application of stack is expression evaluations. Now expression evaluations are postfix, prefix and infix. Postfix, prefix and infix. I will explain you what is postfix, prefix. Okay, it is very easy, all of us know. Suppose this is an expression a plus b. A plus b is an expression. Now you can see that what is a plus b. Plus is the operator and a and b are the operands. Now when the operator is placed between the operands. Okay, that is the infix. That means the expression is actually infix, prefix or postfix based on the placement of the operator. Now when the operator is placed in middle, like in this case it is a infix expression, or while learning C program you must have you are acquainted with, say, I++ and ++i. These are very common increment operator, or minus and I minus. These are the decrement operator like ++ and minus. They are examples of postfix and prefix. Now if I convert this one into prefix, then the operator will be placed in front of the operands. Okay, so plus AB is an example of prefix expression, and similarly AB plus will be an example of postfix expression. Okay, so that means in C program we have been using the iteration variables extensively. Like I told you, in increment and decrement operators we are acquainted with 4 things like ++i, I++, minus I minus, where I is the iteration variable. So they are nothing but postfix and prefix. So as you know that ++i will be evaluated, that is I will first be incremented and then it will be updated, and in I++ that first I will be updated and then it will be incremented. So this is the difference between ++i and I++. If you still have any doubts on this, you can follow my lecture on operators in C, which is already posted in this channel. Okay, you can go through it. But the main thing is that how this kind of expression is evaluated using a stack. And remember that when the operator is and it is fully dependent on the relative placement of the operator. If the operator is placed in between the operands, it is infix. If it is placed before the operands, it is prefix, and if it is placed after the operands, it is postfix. Okay. Now let's move into the queue data structure. It is very simple to realize. Okay, it is very simple to realize. Like suppose a few persons have made a line, okay, to get some tickets for themselves. It can be for a movie, it can be in a railway platform, or it can be for any purpose. So what is the general norm? The general norm is the person who is standing in front of the queue, he must be getting the ticket first. So he is coming first, that is why he is getting the ticket first. That means it is just opposite of stack, that is it is not a LIFO structure but a FIFO structure, that is first in first out. That means whoever is coming first is expected to get the ticket first. That means he came first, he is the first one to get the ticket and leave the queue. That is why it is first in first out. Okay, so what is the difference between the queue and the stack? That first difference is that it is a FIFO structure, unlike the stack which was a LIFO structure. And the other major difference is that when an element is removed, okay, when the element is removed from a queue, it is always removed from the front of the queue, and whenever an element is added into the queue, it must be added into the back of the queue or the rear side of the queue. Okay, now adding something into the queue, that means the method which we are expected to call is enqueue, enqueue, and whenever I want to remove an item from the queue, then the method called should be dequeue, that is dequeue, that is dequeue. That is, for removal we use the dequeue method and it will be operated at the front of the queue, and for insertion we will call the enqueue method and it is always implemented at the back of the queue. Now consider our example of people buying tickets in a railway platform. Okay, they will form a line, and that person who has got the ticket is always the person who entered first and who is at the front of the line. and as soon as he gets the ticket, he is removed from the queue, or in other way we can say that he leaves the queue. Okay, and whenever a new person who wants a ticket enters the platform, he stands at the back of the queue. Okay, that means if that person is newly added into the line, and that is N queue, and the person who already got the ticket was in the front of the line, and after getting the ticket he is removed, so that is D queue. That is as simple as that. And as you can understand easily from this example, that it is a FIFO structure, that is whoever entered first will be leaving first, unlike the stack that whatever or whoever is entering at last will be leaving first, right? Now queue has many applications. Okay, like suppose there are a lot of jobs. Okay, lot of people within a network. Okay, they are trying to access a printer. Now the printing jobs will be stored in the printing buffer. Okay, in the printer buffer in the form of a queue. Okay, because the job will be completed in a serial fashion, because the printer cannot take up two different print jobs at the same time. What it can do, it can always allow the next job in the queue. Okay, it can only add that second job to be done in the queue, because at a time the printer can print only one request from a particular user. Okay, and provided the printer is a shared printer, as I told you that it is a network printer, so many people are trying to access the same printer. Say person 1, person 2, person 3 persons are trying to access the shared printer at the same time, but the printer is incapable of handling the job, okay, concurrently. Then what is the solution? That there must be a printing buffer which is maintained by the printer driver. Okay, that buffer will be holding all the job requests within the queue, and as one user has finished printing, then only the next job in the queue will be taken up. Similarly, CPU task scheduling, you know, that is part of operating system, but CPU also does the same thing, because you know that at a time only one process can access the critical region, so other processes will be waiting in the ready queue in the form of a queue data structure. So as soon as one process is being executed, it is taking up the system resources, the others will have to wait, and as soon as one process is completed, it frees up the critical region, then only the next process in line in the ready queue that will be executed. So these are the technical implementations of queue as far as our computer is considered. Okay, then again, see, in real life scenario, see, I have put up an example here. What happens in a call center? You are calling to your service provider, your phone service provider, your telecom service provider. What happens? You are calling the customer executive. They can put your call in hold because they are running out of executives will be taking up your call. Say all your customer executives are busy. So what is the way out? The only way out is that the people who are trying to get through the call, okay, they must wait, because that person or those persons cannot take up the call of two people at the same time. Okay, that is a serial job. So as the request of one customer is fulfilled, then only the request of the next customer will be taken from the queue. So these are the few examples of, there are others also, as I have already explained, handling of interrupts. Okay, that is another example. So queue has manifold implementations in real life, and as far as computer organization is considered, okay, queue has several implementations. So both stack and queue have practical implementations and applications. So we must learn this kind of data structures very well, and our concepts of stack and queue and simple programs to implement them, we must be well aware of that. So that's all in the theoretical part. Now before I conclude, I decided that there must be some practical part into this course. So I am using Cygwin terminal to execute C programs because that is the best way. I find it very useful to run C and C++ programs. Okay, it is mainly GCC based compiler, and unlike Turbo C, which has limited support for Windows 10, I find Cygwin very useful. It is a way better compiler, the GCC compiler you can get here, so you can follow. I have also made one lecture on how to install Cygwin in your machine, so you can follow that in this channel only. You can follow that and you can install Cygwin and try out your C and data structures program. So let's move into a particular directory where I have actually put up the programs for today's class. So after the LAs, these things are there, that what are the programs which I have already written beforehand to take this class and to demonstrate the various theoretical concepts which I gave you a few minutes back. Now let me demonstrate a simple program on array. Let's open this sumarray.c file. That is a simple command, nano sumarray.c. Now this program finds the sum of the elements of an array and display the result. It is very simple. We have declared an array of size 10 and it's named as A. Okay, that is why I declared is at int A10. It is an integer type of array. Since it is holding 10 integer elements, we can call it as the simplest data structure. Okay, I is the iteration variable and you initialize the sum to 0. Now I am asking the user to enter the elements of the array and then iterating the loops between 0 and 9, because the array elements will be placed at location A2 plus A3 ... till A9, and finally I have to print that the sum is %d, comma sum, because the name of our variable is sum. I think it is very much clear to you. Okay, I will give one example. Suppose the user has entered the values as 1 2 3 4 5 6 7 8 9 10. Okay, so A0 is holding 1, A1 is holding 2, A3 is holding 3, okay, A2 is holding 3, A3 is holding 4, and similarly A9 will be holding 10. So how will this loop be executed? Now initially sum is initialized to 0, so the new value of sum for I equal to 0 will be 0 plus 1, that is 1. Now since we have the user entered the value of A1 as 2, so new value of sum will be 2 plus 1, that is 3. Then again when 3, that is A2 is added to the latest value of sum, it will be 3 plus 3, that is 6, and finally the sum of A0 plus A1 plus A2, that is up to A9, will be 1 plus 2 plus 3 plus 4 plus until 10. So that is n into n plus 1 by 2, that is 10 into 10 plus 1 by 2. In other words, it is 55. So this is how it is computed. Let's check that whether our code is correct. So let's let's compile this using the simple GCC command, GCC sum array.c. then we create the object file as -o sum array, and let's check. Okay, so our program is compiled. We can easily run it using /sum array. Now as per my example, I am inputting the values from 1 to 10, and the result is as expected, 55. So this program is made for any values of n whichever user entered. Okay, their sum will be outputted. Okay, so that is how an array works on a very simple note. Okay, if you have any questions, you can always ask me now. Okay, I will try to explain it, and also you can related to this tutorial, you can post anything on the comment box. Okay, I will try my best to answer them. Okay, sorry, please excuse. Now I will move into the next program, which I discussed as 2D array. Now how a 2D array operates, just check nano 2D array.c. Now this is a matrix like structure. The number of rows is 2 and the number of columns is 3. So recall the theoretical class that 2 iteration variables are required to track the number of rows and the number of columns. And to track the number of rows, my iteration variable is I, and to track the number of columns, it is j. So to read the elements at locations a 0 0 0 1 0 2 and again 1 0 1 1 and 1 2, we need to run a nested for loop, and the first for loop will be for I equal to 0 I less than 2 I plus plus, because the number of rows in this particular matrix is 2. Okay, and in fact it is 3 because it is entered a 2 cross 3 matrix. Okay, so my I value must be 0 and 1. That is why I have written it as I equal to 0 I less than 2 and I plus plus. That means that it can take only 2 values for the number of rows, namely 0 and 1, because it is a 2 cross 3 matrix. And for j, which is tracking the columns, the values of j should range between 0 and 2, that is 0 1 and 2, and that is why the limiting condition for j will be j less than 3. Now after executing this nested for, I am entering the value of each element. Okay, and I am just scanning them, as this is syntax like scanf %d ampersand disp ij, because disp is the name of the array. Okay, now whatever values user has entered, we will be displaying the array elements. So like we read the elements, okay, by inputting through our keyboard, we will be displaying now in the next part of the program. I have already commented it, like displaying array elements. We will write similarly, we will again iterate through I and j. We will use nested for loop, and we will print the value of each value, that is whatever in whatever location. Okay, it can be, now what are the locations as per theory? They should be 0 0 0 1, okay, 0 0 0 1 0 2, that will be for the first row, and for the second row it should be 1 0 1 0, then the value will be 1 1, and then it will be 1 2. As such, you will be getting a 2 cross 3 matrix. Now note this point, that if j equal to 2, then printf/n is there, because at most j can have the value of 2, because we have only 3 columns. So when I will reach this terminal condition, then I will just make a new line, because otherwise the number of rows and columns may get jumbled up and it will be difficult for us to read the matrix properly. That is the reason for this, nothing else. So let's move back. Let's compile this. GCC 2D array.c -o 2D array. And this should compile our program, and it has successfully compiled. So just run them, run the program. So enter the value of display 0 0, that is the first location, the first row and the first column. Let me put it as 1. Enter the value of display 0 1, we put another value of display 0 2 we entered as 0, and let's enter the other elements also. So the matrix, the 2 cross 3 matrix is simple. It is 1 1 0 5 7 and 9 as per our values of I and j. and as per the given dimensions we have obtained our matrix. The next program in question is an application of the two-dimensional array, and that can be shown using the matrix sum.c program. So let's open that. Nano matrix sum.c. But this is a program to add to 3x3 matrix. Now, as expected, we are initializing two matrices as int matrix A 3 3, matrix B 3 3, and matrix C 3 3, where the dimension is given by the size of the array. Now matrix A is 3x3 matrix, so it is 3 3, the size is 3 3. Matrix B is another 3x3 matrix, and when we add matrix A and matrix B, the resultant matrix, or the sum of the two matrices, they must be also of a 3x3 dimension. So our matrix C, which is holding the sum, is also of size 3 3, and the number of rows, columns, okay, they are the iteration variables which have been initialized as int r comma c comma k, and where r and c are the iteration matrix for other iteration variables for going through the number of rows and number of columns. Now let's start. I will come to that k, okay, that what iteration variable k is doing, okay, in the latter part. Now let's concentrate on r and c. It is very straightforward. I already showed you in the last program that how to take input for a matrix, okay, in a two-dimensional array. We were doing the same thing here. We are just trying to input the values and scan them in memory. So it will be a 3x3 matrix, so the number of rows will be traversing from 0 till 2, and the number of columns should also traverse from 0 till 2. So as expected, the nested for loop is something like for r equal to 0, r less than 3, r plus plus, for c equal to 0, c less than 3, c plus plus, and we are getting the elements here using the scanf function, scanf percentage d ampersand matrix ARC. Likewise, we are going to input the elements of the second matrix, and the third matrix is matrix C, okay. It is expected to hold the sum of matrix A and matrix B, so we are initializing it to 0 because initially the sum must be 0. So matrix CRC is initialized to 0, and then see the utility of k. The k is the third iteration variable just to do this sum, okay. Now for r equal to 0, r less than 3, r plus plus, for c equal to 0, c less than 3, c plus plus, we are initializing the third matrix to 0, and consequently we use the third iteration variable, that is k, to do this addition, as for k equal to 0, k less than 3, k plus plus, we are just assigning matrix CRC as the sum of matrix A and matrix B. This is very straightforward. So what is the purpose of k? It is just iterating through the values to give me the final sum, and the iteration variable r is iterating through the rows, and the iteration variable c is iterating through the columns. Finally, again, I already showed you that how to find the output, okay, how to display the matrix, okay. So our purpose is to display the addition matrix, so we will again traverse it using the iteration variables r and c, and we will print the values of matrix C as printf percentage d matrix C RC. So that will be printing all the elements of matrix C, and the printf backslash n, that is just for a new line, so that we do not get jumbled of the number of rows and the columns. They must be separated, right? Because if the rows and columns get jumbled up, then it will be difficult for us to mark them. So if I run this program, the program will be even more easier for you to understand. So let's compile and run this. We will use the simple command gcc matrix sum dot c minus o matrix sum. So what is the object file here? The matrix sum file. So that is the name of the object file. Our program has already compiled successfully, so we will try to run it as dot slash matrix sum. Enter the first element, okay, of the first matrix, that is at location 0 0. So I think that there is nothing to explain here, but still I will just go through. The first element of the first row and the first column will be mapped to element 0 0. So we are just entering a value. The second element in the second row for matrix 1 will be 0 1. So let's just put another value. Again the first row second column, okay, the third column rather, it should be 0 2. We are putting another value. Now we should move into the second row, and naturally it is 1 0, which will be mapped to row number 1 and row number 2 and column number 1. So that value is element 1 0. We have to input it. Let's input it as 5. Similarly, I am not wasting much time here. I am just inputting. I hope you are understanding this. If not, you can ask me. Now as such, the first 3 cross 3 matrix has been entered by the user. Now it's the turn for the second matrix. Let's enter it manually, each element mapping to the particular address, that is mapping against the row and column of the second matrix. So we have successfully entered the both matrices, and the new addition matrix, as you can see, is being displayed, where the value of matrix A00 is added to the elements of matrix B00, matrix element of matrix A01, okay, matrix A01 is added to the matrix B element of A01. So it is very simple. Still you can also check it from the screen, that what should be the value of element 00 in the resultant addition matrix. It should be 4 minus 1, that is 3, and it is 3, as you can also already see here on the screen. Minus 1 plus 9 should be the value of A01 in the resultant matrix, that is 8. Similarly, it should be 0 plus 8 for element 02. Likewise, if you verify, you can easily see that it is the addition of the matrices A and B. If you have any question, you can tell me. I will answer them. Okay, now the last 2 programs, okay, this may be new to you, because these programs will be implementing a stack and a queue. So let's implement the stack program first. Nano stack .c. As you can see that this is a C program to implement stack. Okay, stack is a LIFO data structure. As I already told you a few minutes back, that the most important things which we should keep in mind in stack is that it is a LIFO structure, that is last in first out. You can only operate at the top of the stack, that is to insert anything you must insert at the top, and to remove anything from the stack you should remove from the top only. You should not access any other elements, or in this data structure there is no provision to access anything without accessing the top of the stack. And also the operations for insertion and deletion, we will be using the functions push and pop, push for insert operation and pop for deletion operation. And finally there will be a third function to display. The display function will be displaying the values or the content of the stack at any point of time. So let's explain this now. Stack is a structure. Okay, it is a structure, so I have declared stack as a struct, struct stack, that means stack is a data structure whose type is struct. Why it is struct? Because it is having a structure having two different elements. See, the first element is the int stack, okay, that is an array which will determine the size of the stack, and the other variable is the top, because we have to keep in track of the top all the time, because all the operations are at the top of the stack. You cannot access any other element. Remember, I am emphasizing on this point again and again. So you are type defining this struct okay, as stack stack. Okay, now again we are creating stack s to access the elements. Okay, we are just defining the push and the pop function. Now see here very carefully the return types of the push, pop and the display function. Now push, it is not returning anything, because it is just responsible for entering an element of the stack, so its return type must be void. And for pop, okay, the return type should be int, because you are entering an integer element as per the definition of the stack. You can see that the stack should have the elements which are of type integer, and when I am popping, okay, I must return the integer, that whatever I have popped. Okay, that is why the return type is int. At display the content of the stack, that is very straightforward, its return type should be void. Now the main function starts here. It is just a switch case, where because this program is a branching kind of, that means I will give users certain options, that what he wants to do, whether he wants to insert something, whether he wants to remove something, whether he wants to display, or he wants to exit. So these are the things which my switch case will work on. My switch case will work on the choice of the user, or on the options which the user select. That is why my while is dependent on the options. My options, it is very much clear from the printf statements, that for 1, when the user presses 1, the push function will be called and element will be inserted into the top of the stack. When the option is 2, that is pop, that means one element from the top of the stack will be removed. For option 3, okay, the current content of the stack should be displayed, and for option number 4, the system will exit your program. So I am asking the user to enter his choice. Okay, that is why it is printf enter your choice, and the choice is scanned into the memory. And now we are using the switch case. That is why I am writing it as switch choice, because choice is the variable which the user may have entered. And case 1, as I already explained you, for case 1 the push function is called, for case 2 the pop function is called, for case 3 the display method is called, and for case 4 we are just returning because we are exiting. Okay, now I am asking the user that whether he wants to continue or not. Okay, based on whether he wants to continue, we will execute this loop again and again. That is why if the user has entered 0 or 1, depending on that, we will be calling the options again. Okay, we will get that. That is why our while loop was taking the variable as while option, and the user has given 0 or 1. So based on that option, that switch case will be called again and again. Now check that how we are implementing the push and the pop functions. So we are assigning the top of the stack as max size -1. Again the old concept, that the top of the element, okay, it depends on the size of the array, and it's max size -1, because you know that array element starts at 0. So whatever size I will declare the array, okay, the max size -1, that should be the index of the top of the stack. So if s dot top is equal to max size minus 1, that is a mandatory thing. You cannot write it as max size. You have to necessarily write it as max size minus 1, because max size will give you the size of the stack, and max size minus 1 will give you the addresses of the elements of the stack. Now if when we reach the top, the value of s dot top should be max size minus 1. So if this condition is fulfilled, then we will mention that the stack is full. Okay, if the stack is full, and if it is not, then we will be entering the element into the stack and we increment the stack top by 1. It is as simple as that, because the stack top is maintained always and all the operations are performed from the top of the stack. So when you enter that element, the stack top must be incremented by 1, otherwise the stack will never get full, right? So s dot top equal to s dot top plus 1, that must be a condition which should be placed within the else. It must be placed within the else, is not it? So I think you are understanding. If you have concept of structure, then you can understand this program. Otherwise it may be a little bit difficult for you if you don't have the idea of structure. So if you need more lessons on structure, I am ready to post a video on the same. But for the moment our topic is data structure, so I am assuming that you are well acquainted with structures. Again, let's recall it again just for your understanding. How is the push function being implemented? Now if the stack top is equal to max size minus 1, that means the stack is already full. So I need to necessarily put this condition, otherwise I will get a stack overflow error. So I have to check this condition, and else, that is if the stack is not full yet, then I can insert that element into the stack and I have to increment the stack top by 1 so that it is reaching the maximum size, so that I can keep in track that how much the stack is full. That is why I have to increment s dot top, that is the top of the stack, and s dot stack s dot top. Okay, that declaration equal to num. That means my number is inserted. My number is inserted, that whatever element I am going to insert, that is now the current element at the stack top, and then the function is returning. Finally, let's check that what is the pop function doing. Okay, let's check it. The pop function, it is actually returning some integer value. Just wait. Okay, it is perfectly fine now. I can proceed. There was some issues in the screen. Now what is the purpose of the pop function? The pop function is removing an element from the top of the stack. Now if the s dot top is equal to minus 1, that is the stack is already empty. Okay, so you have to print this, that the stack is already empty. Now that condition is for the stack underflow error, because you are trying to remove an element when there is nothing inside the stack. So that is the stack underflow error. Otherwise, that is else, your number is equal to s dot stack s dot top. That means whatever you have removed the number, and your stack top will be assigned to the next number in the stack, and your top will be decremented by 1, because since you have removed one element from the top of the stack, naturally the size has increased, and the top and the value at the top of the stack, or the address of the top of the stack, that is decremented by 1. This is very straightforward. that for pop you have to decrement the top, and remember top is very important because that is the current value. It has successfully compiled. Now just run this program /stack. As you can see that it is a menu driven program. You have many options. For stack operation 1 you can push anything, that is you can insert. For option number 2 you can pop, that is you can remove. For option number 3 you can display the current content of the stack, and for 4 you will exit. Now let me start by inserting element into the stack. So I will select the option number 1. Let the enter the element to be pushed. Suppose I am entering 3. Do you wish to continue? Yes, I wish to continue. So I enter 1. Again I want to push another element, so I have entered the choice as 1. Let me enter another. Yes, I want to continue. Let me enter another one, so I enter another element. So yes, let me check what are the values. So I select 3. See, the status of the stack is 863. That means the top of the stack is what? The element I entered last, that is the top of the stack. Now let us pop one element. So let's select option 2. Okay, do you want to continue? I say yes. So irrespective of my choice, if I pop, okay, then the element at the top of the stack will be removed. So there is no other options for this data structure. So when I enter 1 and I enter 3, see that 8 is already removed since I choose the pop option, and that is why pop was entering the return value as int. Okay, because irrespective of the choice, when I enter 2, the top of the stack will be deleted or removed. That is why it must enter some integer value. Now the status of the stack is 6 and 3 because 8 is already removed. It was the top of the stack and eventually it got removed by the pop function. And in the course of this program we already saw what display is doing. It is displaying as the current status of the stack. So there is no point in continuing. I just choose 0 and get out of the program. That's it. So this is very simple. If you want this code, I will provide it to you, and if you have any questions you can ask me. Finally, let's check the program on queue. This is the last part of today's live session. And remember, I am telling you that this is not an assignment solving class. I don't solve assignments, so don't send me your assignments here. Only ask questions which are relevant to this topic. If you ask for assignments, it is beyond my ethics to solve your assignments. I can't do that. I can only teach you the basics and I can give you an idea how you solve your assignments, but I will not solve it for you in this platform at least. Anyways, so let's look into the queue program. Okay, it is another simple program. Okay, just recall the concepts again, that in what happens in a queue data structure, it's implement two functions, enqueue and dequeue. Enqueue will insert an elements at the rear side of the queue and dequeue will remove one element from the front side of the queue. I already explained you. So enqueue and dequeue are the two functions which I am expected to implement, and also I have to keep in track both the front and rear. Earlier in the stack I needed to keep in track only the top of the stack, but here I need to keep in mind that I have to keep in track of the front of the queue and the rear side of the queue, because elements are inserted at the rear side of the queue and elements are removed from the front of the queue. So let's check. So this is actually an implementation using array. You can implement the queue in many ways. You can implement the queue using linked list, using pointers, or you can simply implement it through arrays. So since I haven't covered the list here, so I have to implement it using arrays. So the same thing, that you have to find the options that printf, insertion, deletion, and display and exit. Enter the choice, okay, and you are getting the choice from the user. So your switch statement will be switch ch, because the name of the choice variable is ch here in this program. Okay, now if the rear side of the queue is equal to x, okay, now what is the value of x? X is the size of the queue. Now if the rear side is equal to x, that means what? That the queue is already full, is not it? There is nothing you can do about it, because you cannot enter any new elements, or you cannot implement the enqueue function here, because the rear is already equal to x, and x is assigned to, the value of n is assigned to x. And what is the value of n? As you can see, that n is the size of the queue, okay, because you declared it as int qn, and already the size of the queue is defined as n5. As you can see, hash define n5, that means the value of n is 5, the size of the queue is 5. So if the size of the queue, that pointer is equal to rear, that means the queue is already full. Otherwise what you do, you enter the element and increment the rear by 1, that is ampersand q rear plus plus. That means what? The index at q rear is incremented by 1, because my rear side is added by 1. Why? Because one element is entered at the back side or the rear side of the queue. You know this very well, that element must be entered from the back of the queue. So the pointer at the last element of the queue, that is the rear, okay, that is incremented by 1. And if front equal to rear, that means there is nothing there in the queue. There is nothing there in the queue. In other words, the queue is empty, because the front and the rear match. There is nothing called the front and rear, both are same. That means there is no element. Otherwise we have to delete, and you know from where we delete? We delete from the front side of the queue. So when we delete from the queue, the pointer at the front of the queue, that is incremented by 1, because queue front, that is the front of the queue, that is the front of the queue. When I remove something, that is when I delete something, then we delete from the top. That is why it is queue front plus plus, okay, queue front plus plus. And also x is incremented, because when you remove anything from the queue, the size of the queue also increases. Because suppose there were 5 elements and the queue was already full, but you dequeued something, that is you deleted one element, so there is one vacancy for the queue, because it can take up another element in the rear side. So naturally x must be incremented by 1. Now the case 3 is displaying. We will start from the front and will traverse through the rear. Then we can cover the entire queue, because the beginning of the queue is assigned as front and the end of the queue is assigned as rear variable. So I must start with front, and I should traverse until it reaches the rear minus 1, because again the same concept, that the array elements starts at 0, so I must be less than rear. And I plus plus printf %d qy, that means the queue will be displayed, and the case 4 is exit, okay. And in case user enters something other than 1 2 3 4, then the programmer should write that it is a wrong choice. So it's a very simple program. If you have any questions, you can ask me right now. If not, let me run this. Let me first compile this. gcc q.c -o q. That should compile our program. Yes, it is compiled. So let's run this /q. So let us insert some elements. The first element we insert is 4. Remember, the size of the q should be 5 at most, because we already defined it in the program. Enter 5 elements. So we already entered 5 elements. Okay, now let's display them. So we enter option 3. The elements in q are 4, 5, 6, 6, 5. Now elements are inserted at the back of the queue. Elements are inserted at the back of the queue. So whatever element I have entered last should be at the top. Now enter element number 5, that is 5. So that is the front size of the queue, which is given by 4 because I entered it first. And for the 5th element I entered 5, so it should be the last element in the queue. So what is front currently holding? Front is holding the value as 4, and what is rear holding? Rear is holding the value as 5. Now when I insert something, it is added to the rear side, remember. That is why when I added 5, after I entered 4, it is added, it was the temporary rear side. That is why at that position the queue was having the element 4, 5, the 5 was added in the back side. Then I added 6. Okay, so 6 is added at the back of the 5. Again the rear is incremented by 1. Now again I entered 6 as the 4th element, so again rear is incremented. And again I entered 5, so again rear is, the current rear becomes 5 now. So each time the rear side is incremented by 1. Okay, that is why it was rear plus plus. And finally when I reach max, that is the maximum size of the queue, which was 5, which I have already entered. So, and we have already displayed. Now let us delete. So deleted element is 4, because you know that when I press 2, deleted element is 4, because dequeue function or deletion must happen from the front of the queue. It must happen from the front of the queue. So whenever I selected option number 2, automatically 4 is deleted. There is no other options. Okay, so again I choose 2. Then now this time around 5 should be deleted, and yes, 5 is deleted. Now just check the display function. So press the option 3. It should be 665, and it is 665. Now if you want to add again, enter number 6. So if I insert 10, where it is expected to be, it should be added after 5. It should be added after 5. So let's check using display. Yes, it is added at the rear side. That is, the elements are now 6, 6, 5, 10. What is the front of the queue? It is 6. And what is the rear side of the queue? That is 10. I should not tell that it is 6 or 10. Rather, the index, that is the location or the pointer of the variable, that or the value stored at the variable 6. Okay, that is the front. That means if 6 is the element at the front of the queue, then the array index which is holding 6, that should be the front. Okay, and the array index which is holding 10, that should be the back or the rear side of the queue. So let us exit. We already exited from the program. So I think I have covered a lot of things here, and if you have any questions, you can ask me, and I will be answering them. Okay, so I hope you enjoyed this long session, and be prepared to join us for the next session, which we will notify you beforehand. As I told you that it will be a 5-day long session, so wait for the next day when I will be covering linked list in detail. So this is just a try and to check your responses, that whether you are understanding. This is a long course and I tried to cover only the basics. If you need more advanced course, you can always ask me about it, and I will try my level best to arrange such a live session so that it can address your queries. And regarding any questions regarding today's session, you can always email me. Okay, you can check the link in the comment section, and also you can put your questions in the comment. I will be answering them. So that's it. Thank you very much. Next day I hope to see you, okay, in good numbers in the day 2 of this 5-day live session. In day 2 I will be covering linked list in detail, insertion, deletion of linked list, and different types of linked list like single linked list, double linked list, circular linked list. Okay, hope to see you there. Thank you for supporting. Keep watching our channel and support us, okay, and do attend our live classes. If you like our classes, also write them in your comment section, and that will help us to perform better things for you, so that you get benefited in whatever profession, in whatever way you want to learn data structure. Okay, and do check my lectures on C programming also, because if you have limitations in C programming, then this data structure course can be difficult for you. So side by side I request you to go through my lectures on C. Okay, what more, see you soon on day 2 of this 5-day live lecture class. Okay, stay safe, okay, and concentrate on your studies. Hoping forward to see you soon. Bye.